Welcome everybody to 3ds Max 101. This is Mark Gerhard, and today we're going to be looking at lighting, and we'll be looking at standard lighting, photometric lighting, and then we'll be turning our attention to mental ray lighting, specifically the exterior type of lighting that's available in mental ray. So let's dive into these topics. I've got a little scene set up here with just a teapot and some boxes. Move this teapot up in the air. And Max, they change from release to release. In the current release, it's set up so that we automatically have lighting in the viewport with shadow casting. So if you're new to Max, you might not even think about lighting because there's already default lighting in place. The lighting is defined here in the viewport label menu by clicking on realistic. The word realistic there, it brings up this menu, and there's a lighting and shadows menu here. If I turn off shadows, the shadows go away in the viewport. Whoops. If I turn off ambient occlusion, the ambient occlusion goes away in the viewport. And if I choose illuminate with scene lights, normally if there were scene lights in the scene, that's what you would see. So now that I've got that set up, and then also there's additional menus here hidden. I'm going to go ahead and show you the different kinds of lights. Max has two basic standards which you can set under the Customize menu, Custom UI and Defaults Switcher. And in the Custom UI and Defaults Switcher, you'll see that there are initial settings for tool options. There's Max, Max Metal Ray, Design Viz, and Design Viz Metal Ray. And depending on which of these you have set, you'll get different lighting defaults right out of the gate. So if I go ahead and choose an Omni light and click in the viewport and set the Omni light in place, as soon as I've placed that light, suddenly there's a change in the viewport because, whoops, Control Z, because the lighting is set to illuminate with scene lights. Omni lights are lights that shine in all directions. Now the Omni light, if I go to the Modify panel, I'll see the general parameters for the Omni light. The default for this light is to have shadows on now. Let me go back and put shadows on in the viewport so that we can see the shadow that's been cast by the Omni light. And where did that light go? Let's turn all of these on, find the light, say OK, and there it is. Let's move it over here a little bit. When Omni lights are not casting shadows, you'll see an interesting phenomenon. Let me hit P on the keyboard, select this, and rotate around like this. If I take this Omni light and I move it over here, and I set it over here, let's make sure I have it. Actually, if I go to 4 views, this would be a little bit easier to understand that even with the Omni light blocked by this box, the Omni light shines through the box and illuminates the teapot. So this is a phenomenon that you might not expect. Now, as soon as the Omni light shadowing is turned on, then that goes away. But this allows you actually the option, if you're doing interior scenes, to place Omni lights around your scenes to get illumination into the scene if you want. And that's a little secret a lot of people don't know about. Okay, let's go back to the camera view that I created over here, and you can see that even though the Omni light is illuminating this side of the teapot without shadow casting on, there's no bounced lighting happening, the far side of this box is black. If I hold down the Shift key and I drag a second Omni light over here, I'm cloning the original Omni light. I will call this fill light. And now I have two lights in the scene. In the top viewport, you can see the original one, which I will rename key light, and the second one fill light. It's standard practice to use the typical kind of three-point lighting that is the classic lighting that was used in photography and in filmmaking before the invention of computer graphics. Key light, fill light, and rim light are the three standard types of lighting that are usually used. Okay, some of the basic parameters about these lights that will be interesting to understand. How do I change the brightness of the light? I do that in the intensity color attenuation rollout using the multiplier. So let's see, I will choose this light here and I will dim it by changing the multiplier. If the multiplier, or right click on the slider, put it to 0, now there's no light really coming from this. If I start to increase it gradually, you can see that as a fill light, it's adding a little bit of light to the scene, but not a whole lot. In the same rollout, I can add color into the light. Now I'm going to take this other light and I'm going to turn it off temporarily so that we can just see the effect from one light. This light I will add a full multiplier, set it to 1, and left click and add some color to this. Here I've added a bright pink color to it, and now we can see that the light is color is being added. This light comes back on, and now we can see the full effect of this light is showing up on the back side of the box, on the back side of the teapot. Let's zoom around here for a second so we can see that. And if you remember the class on materials, the color of the teapot is also, depending on the material that's in place. If I hit M on the keyboard and I select a particular material, I don't have a standard material on this right now. Let's go and put one on it, standard material, and drag it onto the teapot. And then you can see ambient, diffuse, and specular. So if the ambient is some crazy color, and I'll unlock that and make the diffuse a gray color. Then by changing the value in the ambient, I can affect the color in the shadow areas. That's an odd thing to do. I won't do that. I'll just put a regular material on it. Okay. Now, the type of light that you create, this light can be changed from an Omni to a spotlight or to a directional light. I'm going to change this into a spotlight for a minute so that I can show you the spotlight values. I will rotate that spotlight around here, and just to make things more interesting, let's turn this way. And now if I click on the spotlight, I can see, let's zoom back a little bit here. P on the keyboard gives me a perspective view. I'll zoom back and move over a little bit, make this big. It's nice and visible. And let's also do one more thing. We'll hide the camera so it's out of the way nicely to be seen. Okay, so we notice that this light now is a spotlight. Unlike the Omni light, which shines in all directions. The spotlight shines in one particular direction, and the spotlight has two basic parameters, or two basic parts to it. If we go to the spotlight parameter, we see that there is a hotspot / beam and a fall off / field. If I change the value of the fall off and reduce it, it reduces the beam, the hotspot. But if I raise it up, then it stays the same. Let's come over here for a second and zoom in so that we can see this, see the effect better. Zoom back a little bit here, and we can see the effect of the hotspot and fall off. Usually, the default is to have a fall off that is very close to the hotspot. So there's a small shift. But you can, I think you can see, let me make sure I have a nice intensity of this. We'll set this up to 1. So it'll be a little bit cleaner and clearer to see. And also let's just put this back to a white, so this will be more obvious. So the spotlight hotspot has illumination that is even within the center of it. And then the illumination gradually falls off toward the edge, and then beyond the edge there's no illumination. So because I have that other light turned off, I don't really have a fill light. The only illumination in the scene currently is coming from this spotlight. If I turn shadows on, then we will see quickly the shadow that has been created, and the shadow is completely black. The shadow parameters are controlled in the shadow parameters rollout, and this is one of your best friends right here, the density. So if I change the, I can change the color and the density of the shadow and give it a more realistic effect, or however I want. So notice that if I drop the density of the shadow down, now I have a shadow that's not so black and intense. If I bring that back up, and I can give it some kind of a mood, blue shadow if I want, there we go. So the other thing that's important to know is that the shadows themselves are governed here in the general parameters rollout, and there are different shadow types available. Gray traced shadows gives you a particular type of shadow. The original shadow type is called shadow map, and if you select shadow map, then you control the shadow map parameters in the shadow map params rollout. The shadow map params rollout allows you to soften the edge of the shadow, and that's generally done by controlling the bias, size, and sample range. So if I raise the size here, I don't know if it's how obvious this is. Let's experiment here. Let's change the sample range to 16, and I'm going to do a quick render. F9 is the shortcut to render. And where did my rendering go? Hang on a second. I see we have mental ray set. Let me turn this off for a second and hit cancel. Cancel. I was playing with mental ray just before the class, and I forgot to eliminate it. So actually, you'll notice right now, let's go over to the render setup. It's taking a moment to think about itself. Common parameters, assign renderer. I'm going to come back to the default scanline renderer. We'll be back to mental ray shortly. Okay, F9 on the keyboard. And there we go. So you can see a shadow here. I'm going to clone this window so that we'll have a comparison to look at. Let's put it down here. And let's go and change the sample range back down to 4. And render again. And now you can see a much crisper shadow. So the combination of sample range and shadow map size gives you the ability to control the crispness of the shadow when using shadow map parameters. Let's close that for a second, put those away. Most of the time using a modern renderer, not the scanline renderer, you won't be using shadow map, but instead you'll be using ray traced shadows. There is no control in ray traced shadows quite like what we were just defining, and so ray traced shadows tend to be ultra crisp shadows, and that's what you get. And we'll discuss other ways to get softened shadows in the future. Okay, now I'm not 100% sure why we are seeing this as black, but I'm going to find out in just a second here. And that is that we've talked about how the fall off, the decay, goes from the hotspot illumination out to the sides. But what we haven't talked about is that you can also affect the decay of lights as the light moves away from the spotlight itself. Let's zoom back a little bit and let's move the spotlight back. Right click. Max is not very happy at the moment. So here we go. We'll move this back. And let's render one more time and see if this takes care of the problem that I was experiencing here. No, it doesn't. It's a mystery to me why I am seeing it like this. Okay. But we will continue. If I put a number of lights in place, let's blow away that spotlight for a second and make a fresh one. Cancel that, cancel this, right click, and choose that spotlight and delete it. And let's also have a look at, let's delete this other light. This may be influencing things. I have a feeling that's what may be going on here. So I'll go ahead and I'll create a target spotlight in that direction. And let's lift it up. And one other feature that I didn't show you is that there's something called overshoot. And if I find the spotlight parameter to turn on overshoot, now we have lighting that goes beyond what we were talking about a moment ago. If I click on the target, the line that connects the target and the spotlight, I can move both of them simultaneously. So there we go. We now have a spotlight that is casting a shadow. And now what I'd like to do is create a couple of spheres here. We'll put one there, we'll put one here, so that we can see if we can control the fall off or attenuation of that light. And let's just zoom around for a minute here. Now, one thing you'll notice is that when I select the spotlight, I can see the cone, and when I don't select the spotlight, the cone goes away. I can come over here to the Modify panel, and I can turn on Show Cone, and then the cone is always turned on. That's a nice feature to use. I'm also going to increase the fall off here like that, and then I can turn off the overshoot, and I'll have a nice effect like that. So I should actually check and see my unit setup, and my units are set to standard feet. So now what I can do is I can use the attenuation. Now, light falls off in the real world as it moves away from a light source, like a light bulb, in an inverse square fashion. Now, you can use inverse, you can use inverse square, and those automatically will set those up. Most people that I know don't use those because they find that they're rather uncontrollable. Instead, they set their own attenuation. So I'm going to just demonstrate this with the far attenuation. I'll say turn that on, and let's say end. And now what we should be able to do is end the attenuation. So if I select it back right there, now you can see the light is dim. In fact, if I move it over just a little bit, the light ends before it reaches the box in the back. And clever use of attenuation is a important tool in your toolbox to give the effect of realism when using standard lights. There are two basic kinds of approaches to lighting. One approach is to use standard lights and control everything manually, which allows you the ability to get things exactly as you want them to be through tricks, through manipulation. An alternative approach is, and that's what we're going to look at in Mental Ray, is to use real-world lights that are actually giving off the amount of light in a scene as a real-world light would, and then use global illumination, which will give you bounced lighting. The light will bounce around the room. The light will bounce from one object to another. It's more of the approach of a simulation than the approach of an artist or a painter, someone crafting things by hand. If you learn to master real-world lighting with global illumination, you will have lighting effects that are much more realistic and usually better, unless you're a super master of standard lighting. So we'll look at that in a second here. If I turn on the show, it should give me, you can see this is showing me the actual attenuation as part of the cone here. I'll turn it sideways so this is more obvious. So here I'm changing, this is the far attenuation. This is the end of the far attenuation. This is the start of the far attenuation. I never use near attenuation, but I'm sure there might be someone who figures it out and wants to use it. So there it is. These type of tools are also very useful if you are doing volumetric lighting. So let's render this from the side for a minute. F9 on the keyboard is the shortcut. And you can see the illumination is very unrealistic because the actual beam of light is not visible. So to actually see the beam of light, also my hotspot is really kind of tiny. Let's make that a little bit bigger, like that. To see the beam of light, I can go to Atmospheres and Effects, click on Add, and choose a volume light effect, and say OK. Once I've done that, I have to click on the volume light, click on Setup, and now I get to the Effects tab, Effects dialog box. Why didn't that show up there? Here it is. under atmospheric, volume light, and then let's set this over here. And here we have the parameters for the volume light. Now, if I render this right now, let's see if we see the volume light. So the volume light now appears. We can then play with the density of it. Set that to about, let's try 1.5. I can do whatever I want with that light. One of the most interesting things you can do with it is to add noise. So we'll add noise. We'll give it a lot of noise. Let's make it fractal so it'll be nice and visible. Let's render it once and see what we have now. And now we have a foggy London evening. Now if we take that and change the size down very small, and let's increase the density so it's more visible. We get a completely different kind of an effect. The noise can be turbulent, it can be inverted. Let's play one more and see, so we can see that nice and dramatically. So these are different effects that you can use. And volume lighting is a good way to add mood into your scenes. Okay, so let me just look quickly here and see what else have I neglected to tell you about standard lighting, advanced effects. One thing that's interesting is to use a map. So just like a slide projector or a movie projector, you can have a picture that is projected through this light. I'm going to go and under projector, I will choose maps. I'll choose a bitmap, and let's see. I'm not sure where it's taking me here. Let's find something. Colors.jpg, what is that? Let's just try that, see what we get there. Again, dangerous. I'm doing something without testing it first, but you can see how very quickly now we have added a lot of interest into the scene by simply having a projector light. I use projector lights frequently when I'm trying to see the beam of light very nicely. By having colors and by having something in that beam of light, it very quickly gives you streaks, which is what usually you're looking for in a volume light. Now, one other basic tool that is really very commonly used and also commonly abused is the ability to link the light, or should I say to make a relationship between the light and the objects in the scene. So what I'm going to do is I'm going to click on the exclude button, and I'm going to say this teapot here, I will move it over to this box in the side here. This teapot will now be excluded from that light. If I hit F9 now, the teapot should come up completely black. Well, it's not quite coming up completely black. Maybe, let's see what we got here. Exclude the teapot. Let's go ahead and make a second light in the scene. Omni light. And let's move that Omni light up in the air. And then for the Omni light, we will exclude everything. And let's give that Omni light a bright yellow color. And now let's see what we get when we render. I think I'm going to turn off the projector light so that this will be a little more clear. Hang on a second here. Let's go to the advanced, and we will, for this light here, we're going to go to advanced, and we're going to turn off the projector light, and now we'll render again. Let's probably also turn off the volume light, because that is influencing this. Delete the volume light. Okay, F9 on the keyboard, and now we should see the teapot. However, I think we need to go to a different viewport and see where is that Omni light. Select the Omni light. In the top view, zoom all, and let's move that. Let's select the Omni light. Hang on. There it is. It's selected. Say OK. Move it over. Move it over here. This is a mystery to me why you're getting a black teapot. Let's go ahead and change this to sphere 1. So select the this guy, the target light, and we will, let's just go ahead and take this light, and we will have, move all of these guys back over here, say include sphere 1 over here, say OK, and make sure this light is a color, bright yellow, and let's move those over there and say we're going to exclude them, and let's put this one over here and say that one is going to be included. And now let's see if we get that feature. Okay, so this light, this object here has is the only one that is receiving light from this Omni light. If we move the Omni light over, put it closer to it like that, render again. Oh, wrong viewport. Render again. Now the light is coming from that side. I think that blackness is because of the position of this light. Move it like this, render again. Okay, that's starting to drive me crazy. Let's go over here, viewport, perspective, and lock. Render again. It's not doing what it's supposed to do today. Exclude, okay. We're going to move all those over here and say they're going to be included, and render. Something is not working today. Don't know why. Maybe it's a bug. All right, so we have looked at most of the parameters that you will use for standard lights. Now let's turn our attention to photometric lights. So for photometric lights, I'm going to reset, and I'm going to make an object that I know what the proportions are of the object. I'll go ahead and I'll make a box here, and this box is going to be, let's set it up at 6 foot, tab 6 foot. Okay, we have a 6 foot box. I will make a scale it. I'm sorry, I will make a clone of the box. Hold down the Shift key. The performance is not doing very well today. Cancel that. I think what I will do is let's load up a file that is a room, a building. Give me a moment, and we'll bring this building into place. Okay, so this is an object that has real-world size. And now what I need to do is change the renderer on this, because I believe this one is set to mental ray. Let's see. Mental ray renderer, change it to scanline renderer. And let's select any lights that are in this scene, and we will get rid of them. So daylight, and that should be out of there. And let's just check here. If I turn this off and I see lights, okay, there are no lights in the scene. Now the other thing I'll do is I'll go to 4 viewports, and I will go and make myself a camera, target camera. Let me find a room to work in, about right in here. Okay, that's camera 01. And if we come over here now and come into camera 01, and now we can rotate around. Let's also take that camera, and we will turn that camera into instead of a target camera, we'll make it a free camera, and then it'll be easy for me to raise that camera up into a room in the 2nd floor. There we are. Okay. So now, if I make a photometric light, you will see as soon as we make this light, I believe that this light will become quite dark. Now, actually, this is an old file, and it's put it under realistic, and now you can see this light in the scene. If I raise that light up here, this is a photometric light. Key on the keyboard. Let me zoom in here so you can see this a little bit clearer. Okay, so photometric lights are really not much different than standard lights, except for the fact that they've been designed for design visualization. And in design visualization, we simply want the lights to be real-world lights. So if we go to the modifier panel for that light, you will discover that those lights have templates that we can choose. So I can say I would like this to be a 40-watt bulb, a 60-watt bulb, a 100-watt bulb. If we make it a 100-watt bulb, it's still the only bulb in the room. It's pretty dark. I can make this a 250-watt wall wash, and or I can make it go all the way to a 1,000-watt street lamp. Now, in any case, if I actually render these, the likelihood is this is still going to come up quite black and dark. Let's let it render for a second and see what we get. So it's almost completely dark. And let's make this let's go back to the camera view for a second. Camera 1. Okay. you'll notice there's some light still coming from the outside somewhere, it looks like. Do I see, let's see everything in this scene for a second and see if there's some sort of daylight or something. No, I don't see anything like that. So we just have the one photometric light here. All right. The thing about these lights that is, if you do use these for design visualization, is that here you have an actual photometric web distribution, and a particular kind of light will be allow you to choose what's called an IES file. I'm changing this to a spotlight. I'm going to raise it up a little. So we have this spotlight in the room. And here we have, there'll be a spot here where you can actually put an IES file into place. Now, let's see if I can find. Think that in order for the IES file, I have to have it set to photometric web. And then right here, this is where, there it is. I can open a photometric web file. So I can choose a particular IES file that actually I get from a manufacturer of a particular light fixture. So this is a real-world paradigm. I'm not going to go into too much detail about this right now because I want to show you the mental ray lighting. But I will mention that usually when you render in this fashion, you use something that is called exposure control to brighten up the scene if the illumination is too dull, or you can you can set the intensity. You can change the intensity. So if I'm not using an IES file, if I'm using like a spotlight, then I will have the ability to adjust the intensity over here. So if I take I crank this way up, and let's render it and see what we get. Now if it's still very, very dark, then that's an example that I should be using exposure control. I think the best way to demonstrate that is to move into mental ray. So we're going to do that now. Okay, for mental ray, I will go back to, hold on a second here, I don't know why this is working like this today. Okay, we'll go to mental ray. .max, and we have the same file, same modified, no, all right, and here we go. Okay, there's our file. So I'm going to demonstrate mental ray exterior rendering first, and then we can talk a little bit about interior rendering going forward. Mental ray renderer, I choose on the rendering setup dialog box, and I go to assign renderer, and this is where mental ray is assigned. So in this case, mental ray has already been assigned in this file, and I have the file. Let's go to select from scene and check and see what's in the file. I don't see any lighting in the scene, so I'm ready to add exterior lighting. Exterior lighting in mental ray is done through the systems button over here in the Create panel, you won't find it inside of photometric lighting. You won't find it in here. If you're using V-Ray, it's not in the Systems folder. It's over here in the V-Ray will be added there. You have to have the V-Ray renderer installed to be doing that. I don't have that on this system. So I'm going to come over here to Systems. See it's a Systems, and then I'm going to choose Sunlight. So sunlight and daylight are similar. These are both a directional light. If you remember the spotlight was a cone of light that got larger as it moved away from the spotlight source. Directional light is similar, except it's a cylinder rather than a cone. So the light rays stay constant. Now, a daylight system is simply a directional light that is linked with a location. Sunlight adds another component, which we'll see. So to create a sunlight system, I'll come over here where it's visible, and I'll press and drag out a compass, and then I will move up, and now I've created a sunlight system. So now I can come over here to the, let's make sure this is selected, and I want to make sure that this is a mental ray sun. And where did it go? Why is it not letting me do this? We have mental ray selected. All right. We will choose let's delete that, and let's do it one more time. And let's choose the daylight system. There we go. That was my mistake. Okay, you are creating a daylight system. Now it's recommended that you use exposure control. The value is set to 15. Would you like to change this now? Yes, I would. Say okay, yes. Now let's put out that daylight system. I'll move it over here on the grass so you can see there's a compass there. And then when I lift the mouse, it says, oh, you need to create a sky. You're creating a mental ray sky. Would you also like to add a physical sky as the environment map? Yes, I would like to do that. Okay, and now there we go. And now we've created a daylight system. Now the daylight system has a different kind of control than the controls that we've been looking at previously. This daylight system lets you control date, time, and location. So we can say that it's set automatically at noon. Let's change this to realistic. And let's also make sure that we have illuminate with steam lights on. So now, suddenly we have a very dramatic view here that has changed. Now I can control the time of day. And as it gets earlier in the morning, the light is tinted. The coloration of the light changes. In addition, I can choose the time of year. So let's set this at 3:25. That's today. And let's turn on daylight saving time. What the heck? And we'll maybe make it a little bit lighter, a little later. Okay, now the other part of this that's interesting is we choose Get Location, and we get a map of the U.S. We have many different maps here, and I'm going to leave this at North America, and I'm going to choose San Francisco, California. That's where I am. Actually, I like the light better in the southern areas. Let's go choose San Antonio, Texas, and say OK. It's a little bit lighter and brighter. OK. So now let's choose a camera view. And we have a camera there. And now let's hit F9 on the keyboard and render. Oh, I forgot the important part, which is exposure control. Now this automatically set exposure control, but I really want to show you this. So as soon as it lets me cancel, I'm going to cancel for a second because it's been a while since I've been doing mental ray every day. I've actually been doing a lot of V-ray lately. But what I want to demonstrate is that when you are using mental ray, you want to come over here and choose exposure control. And then we have the exposure control dialog box here that appears. And you click on render preview. When render preview appears, this will give you a very tiny little rendering right in here. And inside this dialog box, we will see the rendering. And then this is the part that makes this so palatable and enjoyable. We can then come down here to exposure control, and we can play with the values here and see what we're going to get and adjust it to taste. Maybe 13.3 might be what I want to use. Now let's see what happens if I render this now. What I'm not seeing is the mental ray, sun and sky. So I want to make sure that that's been applied properly. We'll give it a moment, and there it is. So the mental ray physical sky allows you to create a bluish faded background automatically. Just let this go for a second. Hold on one second. Okay, as this happens, let's look at it in a minute, and then I want to talk a bit about mental ray rendering components. And the same thing will apply to most of your global illumination components. But you can notice right away that the backside of this building is getting illumination, that light is bouncing around, and that the choice of color, the way the illumination is appearing is very realistic. This is something that if you use standard lighting or if you use photometric lighting and then fiddle with it, it's very hard to achieve a really beautiful, realistic rendering. But if you let the mental ray or V-ray, the ray casting algorithms do their work, you can come up with better color choices. It's unfortunate, as if you're an artist, you really don't like to turn over that sort of control to the product at hand, but it really does pay off. Okay, so you'll notice that we're not really seeing this in the viewport. There is a method that you can actually see that in the viewport. You can go to Views, go to, where is it, Viewport Background. If you click on Viewport Background here, then you says Use Environmental Background. If you choose Display Background and say OK, now you'll see that we're seeing that background in the viewport. Hit the P on the keyboard to make this perspective view, and let me also select that object in the scene so that I will orbit around that and if I orbit, whoops, I'm under the ground there. I'm trying to show you the sun itself is visible. And I think the easiest way for me to do that will be to go ahead and change the time of day. So we'll select the daylight, come over here. Now, one of the things that is you won't expect is that in order to change the time of day, you have to go to the motion panel. Okay, and Max is just going so slow right now. When we take a break, I'm going to shut down the computer and start it up again, I'm afraid. Okay, so let's change the time of day to 7 a.m. and there it is. So now you can see the actual sun appearing. And let's make this just a little bit lighter like that. Now this is an example here where this is very, you know, awesome and dramatic, but when it comes to rendering, maybe I want to have a little more exposure control. I'll render preview again. And then when I see it in here, then I will play with it. Now the truth is that I was trained on this before exposure control was even available in the viewport. So now the fact that you can actually see it in the viewport kind of negates my whole workflow. I can actually control this nicely in the viewport. So, I mean, this no longer looks realistically like you know, early dawn, but on the other hand, if I want to do this, I have the ability to do that. Speaking of exposure control gives you some very interesting values here. If you grew up with cameras before the age of digital cameras, you can actually come here and change to photographic exposure, and then you can adjust shutter speed, f-stop, film speed. Now, there's an anachronism. I don't really play with those very much myself, but what I do play with a lot are the ability to affect image control. So in image control, I can say, you know, I need my shadows to be lightened up. I need my shadows to be darker. The highlights are too bright. Let's go 0 on the highlights. Midtones, I can crank those way up. I think that gets all the way up to 4. So you can see suddenly in the viewport you have some serious graphic design kind of controls to make adjustments to your image that bring back the sense of the hand of the artist. Now, I suggest that you use these with in small doses. That's my suggestion. When you make very dramatic kinds of changes to these, it very quickly can become unyieldy. Same with color saturation, white point. These are dangerous tools. Use them with very judiciously. Okay, I think this might be a good time to take a quick break. Nelson, we'll stop this and then take a 10-minute break.
Alrighty.
Okay, we're back. All right, I've restarted Max, and I want to take a little bit of time now to go into mental ray materials, since we didn't have a chance to talk about that previously. So real quick, I will just make myself a box for and a teapot, as we like to do, and M on the keyboard, and we're back into the material editor. what I would like to do is actually let's go to systems and let's apply once again a daylight system. There's the compass. We'll add the scene. We'll add the light. We will create a view here, something like this. Let's zoom in a little, like that, and rendering, exposure control. Let's hit render preview, and then we can play with the exposure control to get it where we want, and we can hit F9 on the keyboard and see what we have. There are two parts to mental ray rendering. We're going to look at the mental ray rendering dialog box here, and it's hiding over here. Okay, so we have mental ray, and for some reason it's not. It didn't create a mental ray sky. So let's look and see. It says it has a sky, but it doesn't have a physical sky. So if we need to do this by ourselves, we go to the environment panel. It does say there's a physical sky, so I'm not sure why we didn't see it. Oh, I think I know why. Let's see if we try it again with a camera view. It's possible that this is an effect that is only visible through camera view. And we render it again, and there it is. So these are things you learn the hard way. Okay, I'm going to make this smaller so that we can look at the render dialog here, the render window. So the thing about mental ray is that mental ray has two components. One component is called final gather, and then the other components are the standard GI. Now, there's in the rendered window here, the virtual frame buffer, there are controls for final gather, for shadow precision, reflection precision, refraction precision, and reuse for the geometry cache and the final gather cache. If I close this and we look at the render dialog, hello, let's close these here for a second. There it is. If we go to the different tabs here, we'll find the things that I'm talking about. So final gather is something that they've expanded over the past few releases of mental ray, speeding it up, and this is the newest method for computing how the rendering is created. Final gather essentially starts from the camera, and the camera itself shoots final gather rays, and then those rays then shoot a second ray, and by controlling those you can control how fast your rendering is and how good it looks. Now, if I close the final gather dialog box, we open up the caustics and global illumination dialog box. This, you'll notice, is not turned on. Global illumination, this is something that if you want to enable that and turn off final gather, this is something that we do frequently when doing interior renderings. This is very complex and kind of outside the scope of a beginning class, so I'm not going to go into this in great depth. Also, I think that you'll find that if you're doing games and entertainment, you're probably not really that interested in this. If you're doing design visualization, you might find that you'll be using V-Ray rather than mental ray. It's good to know about this, but you really can leave this off unless it's required. And then the thing that truly slows things down the most are caustics. But we're not going to do either of those right now. We're just going to, I just want to let you understand that these are there. Mental ray, you can spend months actually learning and mastering these kind of renderers. But I do want to show you, just to expose you a little bit to the materials. When we have mental ray selected as the renderer, we have a whole new option of materials available to us. Now there are, if I click on this button here, this gives me the option to pick what kind of material I want to choose. And the browser here is acting sluggish. I'm going to click and turn that down so that we have the mental ray materials that are available to us. So the history of this product, mental ray, was has been in the film industry for many years. It's a renderer created by Mental Images. It's been around 20 years or more, I believe. And they worked up a deal with Autodesk a few releases back. The original releases of mental ray were totally inscrutable and no one could figure out how to use them. Then they came up with the Arkin design materials, and those materials were really very good. And we're going to look at those right now. Then Autodesk actually tried to make these materials more simpler to use, and they came up with a new version of mental ray materials, which they call Autodesk materials. And all of these Autodesk materials that you see here, Autodesk ceramic, Autodesk concrete, and so forth, they were designed with the idea that someone like an architect or a design visualization mechanical engineer using Inventor or architect using Revit would want to use these materials without really knowing anything about them. And so these materials were designed in that fashion. But essentially, all these materials really are a rehash of the Arkin design materials, and those are the ones that I use most of the time. But we'll do a quick demonstration of this to show you. So if I pick an Arkin design material, then the thing that I enjoy about these materials, let's go and we'll put that on that teapot, is that then we can choose a template. So from that we can say, what is that teapot going to be? Will it be a chrome teapot? Will it be a brushed metal teapot? Is it going to be glass? And I can choose these, let's say a copper teapot. And then what that does is that then plays with all of these settings. Now if you look at these settings, you'll see that there's a familiarness to them. Diffuse, well, standard materials had diffuse. There's a color swatch. There's a swatch here to put a map. Reflection, there's a reflectivity, glossiness, samples. There's a fast interpolation. There's metal material. Refraction, translucency, anastrophe. These are all things that you might have seen in the standard materials, so that you'll find the mental ray materials are familiar to you. BRDF, bidirectional reflection, something, something. What this is about is this means that depending on the angle that you are looking at something, that the reflection changes. Self-illumination. Now self-illumination is actually very genuine in this. If you turn on self-illumination, then you can actually have it illuminate the scene if you want. We're not going to have it do that right now, but this is a very nice effect. Special effects, you can add ambient occlusion at the material level. Round corners, you can take objects that are sharp and that you can give the illusion that you've shaved off the corners of them. So there's all sorts of interesting stuff going on here. I just wanted to expose you to this and to do a quick demonstration of how this looks. Now, I'm going to make another material. This will also be an Art and Design material. I'll put this on the base here, and I will choose a water template. Where did the water go? Water reflective surface. Okay, there it is. Let's go ahead and render this. F9. You can use F10, which brings up the dialog box. F9 brings up the last rendering based on the last render settings that you used. And let's see what we get. So it's computing the final gather points first. And you can reuse that. So if you're rendering over and over and over again, you can turn on here, reuse final gather, and then this part of the computation will go away. And now it is doing the actual rendering. This is called bucket rendering. So it happens in buckets. You can control the bucket size. If you practice this, you can uncover what is the optimum for your scene to make it the fastest rendering possible. Give this just a minute to render. And there it is. And you can see that we have a very convincing water material, a very convincing copper material, and a not so convincing sky or ground plane. But there are tricks to put clouds into the sky, or another thing to do is to simply fuzz out the ground plane. But materials in Mental Ray are so easy to use, and it's really worth checking out. Now, just to show you this, I'm not a big fan of these, but they serve some function. So here is the version of water that has been, the UI has been removed, has been limited to become Autodesk water, and now you choose what kind of water do you want. Swimming pool water, generic sea ocean water, pond, lake, stream, reflecting pool water, and then performance tuning, and then overriding the reflection depth. These are the only choices that you have, the wave height. So this gives you an example of what you can accomplish with Mental Ray materials. One other thing that I haven't really shown you was when doing interiors, there's a thing called Sky Portal. Really quickly, let's see if I can make just something to demonstrate how you'd use the Sky Portal. And I think the simplest way for me to do that will be to make a Boolean. So I'll make a box over here. It'll come up like this, and then I'll make another box off of the front of it. I'll take that box and I will run it through that so that I can cut a hole in this. You'll remember this from the first couple classes. Compound object, pro Boolean, start picking, pick that one, and now we have a hole in the wall there. Let's go ahead and enclose this so that it'll be a bit more obvious. Just take a second to do this. Standard primitives, make a box, one over here. Okay, and we'll make another one over here. And we will copy the, let's get rid of the water material. I will choose another Art and Design material, something simple like a concrete. Again, hold on. Something that'll render quickly. concrete. And we'll replace that there. And we'll make a copy of that. Hold down the Shift key, move it up. And this will be our floor. Our ceiling. And we'll make it a copy and say OK. There we go. Okay. So now, let's take the camera and move the camera around a little bit so we can see into this room here. Let's render this and see what we get. We have a daylight system outside. And the light from the daylight system is coming in through the window. Now, this isn't a great test because the light is actually coming in from the front here as well. And notice that the rendering is taking a bit more time because now there's more walls to for the light to bounce off of. But you can see that it's fairly dark. The direction of the light is not pointing at the window, so it's really not, the window is not really, that hole in the wall is not really getting much light into the scene. And this is a common thing that you're going to run into if you're doing interior environments with mental ray or V-ray, that you have a problem with illumination. Now this is actually a little bit slow because of the chrome, so I'm going to stop this because what I want to really show you, let's get rid of the chrome and then let's show you the lighting that I was talking about. So M on the keyboard, and we will pick another material that's an arc and design material. And we'll just do some kind of a plastic. Here's a glossy plastic, and we'll put it into there. Okay. So if you need to, notice actually that the light in the left viewport, you can see the direction of the light is such that it really isn't projecting into the room at all. Now, if I was going to render this, I would do what I showed you before. I would go to Exposure Control, click Render Preview, and then change the exposure value like that. But what I want to demonstrate, so I might set this to something like 11 or 10 to lighten up the room. But sometimes you don't really have that option, and then you can use what's called a sky portal. Now, in a sky portal, this is it's a little odd. This is found in not in the systems, but in photometric MR sky portal. And I make this with an auto grid, and I drag it out like this, and I make it just about the size of the window, and I set it there. Let me make a right-click here for a second and make this P on the keyboard. So we have a perspective view, and I'm going to move this around so that you can see what we have created here. So notice that there's a little arrow demonstrating the direction that the light is headed in. I don't know if you can see that. What I'm going to do is I'm going to say flip light flux direction, And now that light value is turned the other way. I'm also going to move this portal so it's on the outside. And if I make this not wireframe anymore, but shaded, then it'll be a little easier for me to see that I'm really on the outside. There we go. Now, if we go ahead and render this, we won't see much of a difference yet because of the multiplier is set to 1. Let's set the rendering down to be a smaller resolution so it'll happen quicker. Rendering, common. I'm going to make this 320 by 240. I'm going to close this. I'm going to choose show safe frame so that I can see it. And then I'm going to adjust this something about like that. Move this over a little bit. And let's move this. There's a light leak happening here. So we will lower this so that we know that we have light only coming in through that, that window. And then we'll go ahead and we will render F9. Final gather is being computed. Final gather has completed its computation, and now the rendering results. So let's clone that one. So we'll have one for comparison over here. I'll set it over here for a second. We'll bring it up in a moment. And now what I'm going to do is I'm going to select that light and I'm going to put a multiplier on. I'm going to try a multiplier of 40. Now the truth is that I really don't know yet what that multiplier needs to be. Maybe it needs to be 400. Maybe it needs to be 4,000. You have to find the sweet spot based on the combination of what you have going in your scene at the moment. So let's start with 40 and see if it does something. And already I think you can see the illumination is brighter in the scene. If you get seriously into mental ray, it's good to take up knitting, or I know someone who learned to play violin while she was waiting for her mental ray renderings to render. I think it's called mental ray because you go mental sitting here waiting for it to happen. Truth be told, okay, so notice, let's bring that up and compare that with this one. So I think you can see the subtle difference that's happening. By putting the multiplier to 40, now suddenly the light is being pushed into the room and you're starting to get the reflection there. If we really want to go crazy, we could, quadruple this. Let's say let's see what happens if we do 200. I'm going to, again, clone this one. And okay, so now we have this one. We'll set this down here. We'll set this one down here, and we will close that and close that, and we will render again, F9. An alternative is to change the direction of the light, try to get the sunlight so it's actually pointing into the window. The alternative, when you have exterior lighting for large interior scenes, is to go back to the original methods of photon generation. And I showed you the global illumination dialog box there. Photon generation is something that you can use to illuminate a scene, an interior scene, when these type of tricks don't satisfy. Okay, and it looks like this is the one that we're getting now. And now you can see that by setting that multiplier to 400, the difference, very dramatic. Now, let's zoom in on this one for a second. It's a little fuzzy, but the one thing that I hope that you are maybe starting to notice is that mental ray equals beautiful. Global illumination, even when it's like just whack, it looks beautiful. And so that's one of the reasons why we put up with the difficulties of mental ray or V-ray, because by going the route of simulation rather than the route of artistic control, you instantly, you tend to get things that really just look aesthetically more pleasing. Okay, we've talked about lighting today in pretty much great length. The next topic, I'm going to just spend about 10-15 minutes giving you some of the basics of animation, so that the last class, which we'll meet next week, we'll have time to go into some more serious aspects of the biped system. So let's reset this for a second here, and I'm just going to, I'm not going to do anything fancy at all. I'm going to make some teapots jump around and make some cones jump around, but I want to demonstrate to you some of the fundamentals about setting up your scene for animation. So the first thing that I want to show off is, let's make this one view. Let's just start with cones to demonstrate linkage and dummies and so forth. So let's have a cone, and we will call this Papa Cone, and then we will make a second cone. We'll call this one Mama Cone, and we'll make another one, and we'll call this Baby Cone. So when creating objects for animation, we create what are called hierarchies. If we look at these three cones in the select from scene dialog, we see them like this, equal. If we pick up and move one of these cones, it doesn't affect the movement of the other. We can create a hierarchy by choosing select and link. With select and link, we start with the child, we press on it, we get a dotted line. The dotted line, then when we move it over a suitable object, notice that the change in the icon. That is now linked to the baby cone, is now linked to the mama cone. We click on the mama cone, again, press and drag, move it to this one, and now we have the linkage occurs. Now let's see if we see, oh, hold on, cancel. We have to go and select object again, and now we can see this display children. And now if we display children, we now see an indentation. This shows us that we have a hierarchy. The hierarchy allows us so that if we select and move one particular object, which is the parent object, then the child objects move along with it. If we rotate, go auto key on, go to frame 25. If we rotate this object, then the rotation is passed up to the object. If we scale the object, the scale is passed down to the objects. We can control this. If we select a particular object and go to the hierarchy panel, we can find there's a link info. And the link info allows you to turn off the inheritance. So let's suppose we want to turn off the inheritance of the scale in that object. Now, notice that the scale occurs to the smaller object, but that has been turned off by the bigger one. Now, if we actually had turned off the rotation, I don't know what we're going to get here. Let's see. The other ones don't rotate with it. Now, we can use controllers to actually animate this process so that it happens in a particular frame. I'm not going to go into that right now, but I just want to show you if I click on a particular object and I go to the motion panel and I choose Assign Controller. Let's move this over a little bit where you can see it a little bit more. That each of these has its separate controller. If I take the rotation, for instance, and then I choose Assign Controller, there's all these different controllers that give me an option that I can use. And each one of these has their own particular sets of parameters which can be used. Max is a very powerful animation system. Despite, people always think Max is the great modeling system, Maya is the great animation system. The truth is Max actually is quite capable for animation as well. It has so many different options to it. The problem is understanding how to use them. Okay, so so this shows you control objects. Now, it's very common to have many different objects that are all going to be attached to one object, one parent object that is created. It's called a dummy helper. So if I make a, let's make a dummy object right here, and then I'll make a few other, let's say, some cones. Make one there, make one here. And now I'll link this guy to the dummy object. Take this guy, link him to the dummy object. This one, link it to the dummy object. Turn the animate button on. Go to a particular frame. Rotate this around. Turn auto key off. Play the animation I just created. Okay, there it is. Let's move this over so it's a little more visible. So dummy objects are very frequently used to create complex animation of all sorts. Okay, more basics. The animation of a particular object is controlled in a number of different places. In the timeline here, we can select a particular object, and then we see the keys that have been created for that object. Those keys, if we right-click on them, we get a list here that allows us to choose which particular track we want to look at. So I'm going to choose the scale, and then we get a dialog box like this. And this dialog box allows us to look at the first key, the second key in this way, and to change the values of it here. We also get to play with the interpolation between keys. Let me make two other objects that will demonstrate this. We're going to have a race of teapots. There's one teapot. In fact, let's go ahead and get rid of these guys for a second. And let's make a copy of this teapot. Okay, give this one a different color. We got the green teapot, and we got this teapot. So if I animate this, auto key on, and I will take this guy here, and let's go to frame 50, and we'll move him up to there. Now that was 7'9", is where it said it was. Okay, we'll take this guy and we'll move him up to past the finish line as well. We play the animation of these guys right now. Hit the play button. They both move simultaneously. But we can take one of them, the green one, and we are talking about the X position. And we can say that we want this guy to now I can never remember which these are. Slow in, slow out. We'll change it to this one. And then as it approaches, we'll change it to this one. Now when I can't remember these, I go to the help system. I go to 3ds Max help, and I'll type in key tangents. And let's see if that brings up something that will tell me. Yes, yes. How do I turn this off? Thank you. Okay, index. It's loading. Hang on. This is the price for being connected. And we have to do this because there are no tool tips on those icons. Key tangents. Let's see if that brings it up. View. Key tangents. Key tangents. There we go. Okay. Set tangents to fast, set tangents to slow. So if you need to know what they are, set them to linear, set them to smooth, set them to spline, set them to automatic. There they are. So now if we hit the playback button, come on. It's probably not obvious, but notice that they're moving. Let's grab this. Let's grab both these guys, and let's move this to frame 100. And I think it will then become more obvious that Maybe right in the beginning it'll be obvious. Oh, did somehow these get changed? Let's change this one so that it's the opposite. So it goes like that, and it goes like this. And this guy, are these instances of each other? Why are these changed? Like that one, and like that one. Okay, that looks like that. I gotta make sure these are not, they shouldn't be instanced. All right. Okay, select that one, get rid of its animation. Okay, that works. That one, auto key on. Bring it over here. Right click, X. Well, let's just see if these look different right now. And let's just make sure that one, X. Okay, so that one should be different. Not terribly obvious. Another way to see this would be to show its trajectory. To see its trajectory, we click on Object Properties, and we say Trajectory. And now, if we choose this one, and again, Object Properties, see Trajectory. So it's just not very obvious that, oh, I wonder how come I can't see. Okay, I can see both of them at the same time. I should be able to change this by going to its X position, and let's go here and make this with handles. Make this with handles. And then let's actually go to Track View, Graph Editors, Track View, Curve Editor. So the Curve Editor lets me see, okay, you see the way this teapot is bold? That makes it say that it's a it's an instance. So why doesn't it let me make it unique? Let's see if it really is an instance. If we go back to the track view and we choose its X position and we choose that, if I right click on it, you'll see I get the same one that I was looking at before. And I should be able to select it and change its handle like this. There we go. There we go. So notice what I'm trying to show you now. Each of these little dots here represents a key. So by doing this, it's going to accelerate as it gets to the end. It's going to be hanging back when we play this. Now let's see if I've been able to succeed in this. There we go. So now I can very clearly see that one of them takes off quickly and this one takes off slowly. Slow in, slow out. Track View is one of the tools that we use when we have complex animations. We have the dope sheet. Let's have a look at the dope sheet for a second. The dope sheet, let's see if I can find the objects in the scene here. Here it is. So this shows me the keys. I can switch back and forth by going from modes to the curve editor or the dope sheet right here. In addition to the curve editor and the dope sheet here, I actually have a mini editor down here. I can click and I can get the same tools right here down below. The other piece of the puzzle that you need to know about is over here. There's a time configuration dialog. The time configuration dialog allows you to control the keys. So here we can have, if we say key steps, we can choose whether we're just showing position, rotation, scale, which keys we're showing or not. This is also where we control the length of the animation. We can scale the animation so that it happens over a shorter period of time. So right now we have 100 frames. If we say we want to make this 300 frames, we choose rescale, say OK, say OK. Let's close this down. And now we find that the animation is over 300 frames. Let's select these here, and if I right click, where is it? Configure. I can also show range here, and then I can stretch out my animation this way if I want to. So now animation takes place over 300 frames. I don't know what I did here. Look at this, crazy. Why it's going backwards. It's going backwards because of whatever I did here previously. So these are all the basic controls that we have. And I'll show you one more and we'll call it a day. So one other method for animating position is to use a different kind of controller for position called a path controller. Let's go ahead and make a path for this object to follow. There's a path. We'll select the teapot, come over here to the motion panel, and then we got that teapot selected, teapot 3. We'll go to position, and we will assign a controller, and we'll assign a path controller or constraint. Add the path, choose the path, and now play the animation. And you can see that the controller is being used for position there. There's lots of different controllers. They can be used in different ways. Just for the heck of it, let's make one more just to demonstrate. Here's a teapot, and I'll use a noise constraint or noise controller for its position. So let's see, noise position, say OK. And let's see, what do we have to do with it? You can see it's just jumping around like that. So if I, let's see, I will increase the frequency of this just to make it go crazy. But I'll decrease the strength. Let's make this about 11, make this 11, and let's leave the Z at 0. Okay, let's play the animation, see what we get. So that one teapot is just jumping around because it has a noise constraint on it. It's governing it. There's lots of different controllers and different tricks that can be played with controllers. That's really, again, outside the scope of a beginning class, but this gives you a little bit of a taste of where to find these and where to go exploring to see them. There are controllers also at the transform level. The link constraint and script controllers are two examples of that. Okay, next class we are going to go into the basics of character animation using the biped system, and we will also look at character skinning and character bone construction. So we won't go into some of the other newer systems such as CAT, but we will look at some of the basics of the biped system. And until then, if you have a chance, play around with some of these and go exploring. All right, that's it for today. Thank you.